just going to write this problem on my paper. The problem I'm going to look at will be 3/7 times 7/10. Now, my students are in the classroom with me, and from time to time I will talk specifically to them. But just a reminder, boys and girls, when we have two factors, in this case 3/7 and 7/10, does it matter the order in which we multiply? Does it matter?
No.
No, it doesn't. We've got properties like commutative property that says we can rearrange those factors in which way we want to, and we can do it that way. So what I'm going to do then is I'm going to start out actually with 7/10. I'm going to fold my paper or make it into 10 parts, and I'm going to shade in 7 of those 10 parts. Then I'm going to shift the paper and make it into 7 parts and shade in 3 of those, and where they overlap, that will tell us what our product is. So I'm going to set the microphone down. Hopefully you can pick me up. Hopefully. Let me double check something real quick, make sure it's actually recording, and it is. Alright, so I'm going to set the microphone down. So the first thing I'm going to do with this piece of paper is I'm going to fold it in half. Now, when I fold my paper in half, I'll then go back and I'll make 5 parts here and 5 parts here. But I'm going to go ahead and make this crease more prominent. Now, when I make this into 5 parts and this into 5 parts, what I'm going to do is I'm just going to eyeball it. I mean, I'm not making these to scale. I just need a representation of what 7/10 would look like. So I'm going to kind of come over here and carve out a part. Make that line a little bit better. Then I'm going to take this part and divide it into 2 and then go here. Now these, of course, are not to scale by any means. I would like for them to be, but they're not. Now I'm going to go ahead and make a part here. And then split this up into some more. Okay. Now, let's see if this, sure enough, is 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to say that none of these parts are to scale, so there you go. Now, I need to shade in 7 of these 10 parts. Now, when I shade in 7 of these 10 parts, I'm not trying to get rid of every bit of the white space. I mean, I'm just trying to show that these are taken up. So there's 1, 2, 3, 4, 5, 6, 7. So I got 7/10. Now I need to represent that 3/7. So I'm going to take my paper, I'm going to shift it over like this, and I think I'm going to have to use an ink pen or something, because it's going to get very busy here. I mean, there's going to be lots and lots of individual units. I'm going to have actually about 70 units there. So let me get a better marker. Okay, now I'm going to make 7 parts here. So let me see how I could do this. I'll go ahead and make 1 part there. And I'll divide this, what's left, in 2, and then make thirds of each of these parts. Right. Now, I'll go ahead and make there, and there, okay, and there, and there. Now let's see if I sure enough have 7 parts here. 1, 2, 3, 4, 5, 6, 7. And I do. Now I'm going to use a different color to highlight or fill in those 3/7. So I'm going to go ahead and fill in here. There is 1, 2, 3. So I have filled in 3 of the 7. Now, to find the product, what I need to do is see how many units overlap that are filled in. That would be my numerator, and the denominator will be the total number of units. Now, I know I have 7 units this way, 10 units this way, so 7 by 10 is going to be 70. That's going to be my, that would be my denominator. And let's see how many of these overlap. I have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So I have 3 by 7, and that's going to be 21. Now I want to point something out. Here, when I had my problem, I said a second ago to find my denominator, I know it's 7 by 10, and I got 70. Then to find my numerator, I said I had 3 by 7, and I got 21. So if I just multiply straight across, I actually didn't need to make this model, but just to give a representation, I did. Now I need to simplify my answer, reduce it to simplest terms. And I know that with 21 and 70, I'm looking at, and I know that 2 is not a factor of both. 3 is not a factor of both. 4 is not. 5 is not. 6 is not. But 7 is. 7 is a factor of both, and that's the greatest common factor. So 7 will go into 21 3 times. 7 will go into 70 10 times. So my final answer is 3/10. So 3/10 of this area model is the product. So 3/10 overlap. Now I hope that I hope that this example that I did helps you better understand how area models can represent fractions multiplying other fractions.